And then we have useful statistical functions. Again, here is another series with 10 random numbers from normal distribution. So you can have mean, okay. Then we have median. So now we can use the mean, median functions from NumPy, in which case you have to do np.mean. Now this one is mean function from pandas. Okay. Of course, it's going to be the same value. So np dot mean of S6. Okay. Obviously, it's going to be the same value, but this one uses the mean function from NumPy. Now that one, the first one, the mean function is coming from pandas. Yeah.
Does the pandas just allow for like a cleaner?
No, no, they both are the same.
Okay. I just didn't know if one was more efficient.
No, there is no preference between the two. No, but if there is no corresponding function for mean in base Python. So there are some other functions in base Python. Base Python is not that efficient. So if you have an alternative, if you have a function in NumPy or pandas, you need to use the pandas function. Between NumPy and pandas, it's the same thing. So pandas actually sits on top of NumPy, so oftentimes it uses NumPy to make the computations. There is one difference though, and that is in standard deviation. Okay, I don't know why this is so. Remember, in NumPy, the denominator, the default is population standard deviation. Standard deviation formula is square root of sum of squared deviations in the numerator divided by either n or n minus 1. The denominator is n for population standard deviation, n minus 1 for sample standard deviation. In NumPy, the denominator is n by default. If you want sample standard deviation, then you have to say dd of equal to 1. Okay? So if you don't say dd of equal to 1 in NumPy, it's going to use dd of is equal to 0. But the opposite is true in pandas. Okay, if you simply say std and say nothing else, then it's going to give you sample standard deviation. So you see here the same thing. I'm specifically saying dd of 1, and here I leave that out. Both gives you the same answer. Okay. So this and this are exactly the same. If you want population standard deviation, you have to specify dd of equal to 0, and you see that that's a little bit different because the denominator is n here. And you see np dot std, if you specifically use the NumPy standard deviation, then the default is population, so denominator is n. So you have to keep that straight. So if you use NumPy and you want sample standard deviation, then you have to specify dd of. So if you use np.std S6, okay, then you see the last one is same as these two. So pandas dd of 1, okay, is default, you don't have to say, whereas for np you have to say is dd of equal to 1. Okay. Then there is another function, very useful function in pandas, that is describe. So if you do s6.describe, it's going to give you a bunch of useful statistics. Okay, it's going to give you a mean. So start with count, how many there are, what is the mean, what is the standard deviation, and then it gives you the, I don't know whether you're familiar with box plot. Box plot is a way of plotting the distribution of data. So the two ends are minimum and maximum, and in between you have 3 percentiles. So minimum and maximum, the midpoint, that's your median. Okay? So the midpoint of the top half, the midpoint of the bottom half. That's the 25% and 75%. So if it is equally distributed, then you will see these differences would be about the same. But if the data is skewed, okay, there are a bunch of values, but there are some values which are really large, then you will see the skew in the box plot. We will look at box plot when we get to plotting with Python. Okay? So the describe function gives you some useful statistics about the data, and then you can chain the functions in this way. So you have ABS and then sum. So that means it's going to do absolute value first. It will make all the negative values positive, and then it'll sum it. And if you do the opposite, of course, if you sum and then do ABS, so it will do the sum first and then ABS. I guess not. Float, okay, there is no ABS function for that. Okay. Now your turn. Create a pandas series S9. So this is okay, so SQ9, 20 numbers between -20 and 20. Okay, so let's first do np random dot seed 1. So everything will be reproducible. You'll see the same result like I do. Okay. Now SQ9 equal to what? PD, well, so let's do it this way. So what we're going to do is we're going to generate NP random. Okay. So from random, we want random numbers between 20 and, so it's not random integers, we want random numbers. So random integers, you would do rand int. Okay, so I guess it is random. So if you want, well, yeah, let's okay, so random will be just 0 to 1, I guess. Yeah, that's just, okay. Let's not, okay, this should be the integers, random integers. Okay, so that would be rand int. And then you say -20 to 20. Okay, and we want 20 of them. Okay, so that's going to generate 20 random numbers between -20 and 20. But we want that to be a pandas series SQ9. Okay. So we want SQ9, we want this array to be converted into a pandas series. So that would be pandas series of that. Okay. And then if you do display SQ9, then it's going to give us that series. Okay. So we have 20 numbers, and you see that it has the implicit index starting from 0 through 19. Okay. So random integer between -20 and 20 of them, then it creates, this part creates the random numbers as an array, and then the pd.series converts the array into a pandas series. Okay? Everybody created SQ9? You got it? Okay. So now we want find the mean and standard deviation of the pandas series. So how do you do that? SQ9, okay, and then say mean. So that's going to give you the mean. Now SQ9 STD, okay, remember this is going to give you sample standard deviation. The default is sample standard deviation. Now if you do NP STD, that will give you the population standard deviation. You have to keep that in mind. Okay, so that's our B. Okay, and then C we want find the descriptive statistics of the series. And remember, this is one of the most useful functions that we will be using when we try to understand what the data is. We know descriptive statistics for numerical data is very useful. So SQ9 describe, okay, so that's going to give you the descriptive statistics. So mean, standard deviation, count, mean, and standard deviation at the top, the 3 basic statistics, and then the 5-number summary. This is called 5-number summary. And 5-number summary is what is used in box plot.